Welcome. On this video, we're going to be discussing the sum and the products of roots for any quadratic equation. So let's get started. So let's take in consideration just a quadratic written in standard form, and that is ax squared plus bx plus c. Remember from your previous classes that to solve quadratics, we can use the quadratic formula. And the quadratic formula is written as minus b plus minus square root of b squared minus 4ac divided by 2a. And what we want to do is develop some kind of a formula which we can use to properly find out what would have happened if we would have added the solutions for any quadratic formula and what would have happened if we would have multiplied the solutions for any quadratic formula. And keep in mind that quadratics are those equations whose highest exponent is 2. So therefore, we are guaranteed to have two solutions. So what would happen if we would have added both solutions for any quadratic formula? That's the first thing that we're going to be discussing. So let's start by looking at example A. So what result will we obtain if we find the sum of the solutions of a quadratic? And again, remember that quadratics, they have two solutions. And how do we get those solutions? Well, we can get those solutions from the quadratic equation. Now notice that here we have a plus and minus, which means that this quadratic equation, if we use the plus, so let's call this x1. So x1 is going to be my first solution, which is just going to use the plus side of the quadratic equation. And my second solution is going to use the minus side of this quadratic equation. And the objective is what would have happened if we would have added both solutions, which in this case, these are both solutions for any quadratic. So what would have happened if we would have added those two solutions? Well, let's see. We would have got our first solution. So b squared minus 4ac divided by 2a. And we would have added our second solution. But what happens if we combine or we try to simplify this? Well, notice that they both have the same denominator, so that's fine. And what ends up happening here is that those square roots, because notice that here we have a plus square root of b squared minus 4ac, and here we have a minus square root of b squared minus 4ac, they're going to be canceling each other out. And if they cancel each other out, what else do we have? Well, we're going to end up with the following. And if we keep continuing, we keep simplifying this, we're going to get minus b plus minus b, so that's minus 2b. And they both have the same denominator, so it's going to be 2a. And if they cancel out, the 2's are going to cancel out. So now we're going to get the expression minus b all over a. So what we have just shown is that for any quadratic, for any quadratic equation in the form of ax squared plus bx plus c, the sum of its solutions will always equal to the expression minus b over a. And this will always be the case. For any quadratic, it doesn't really matter what it is. If I get the coefficient of x, and I take the negative, and I divide by the coefficient of x squared, that will always give me a value, and that value will always be equivalent if we would have added both solutions in any quadratic function. So what would have happened if we would have multiplied, or if we wanted to find the product now? Well, we're going to use the same technique. We're going to say, well, I don't know what my solutions are, but I know that from the quadratic equation, one of my solutions is going to look like this. Using the plus of the quadratic formula, and my second solution is going to come from the minus of the quadratic formula. So now, what would happen if I multiply them now? So if I multiply both solutions, I'm going to have the following. So let me just rewrite my first solution, which is going to use the plus b squared minus 4ac all over 2a. And now I want to multiply this by the minus. So b squared minus 4ac all over 2a. Now let's multiply this, which in this case is going to get distributed. And that's going to be equivalent to my b squared. And if I distribute this now that's going to be equivalent to plus b square root of b squared minus 4ac. Now, if I distribute the second term, if I distribute it here, that's going to give me minus b square root of b squared minus 4ac. And if I distribute one more time to here, that's going to be minus, and we're going to get to the second exponent. So b squared minus 4ac all to the second exponent. And this is going to be divided by 2a times 2a, which is 4a squared. Now, that doesn't look nice, but notice that some things are going to happen with this. Notice that these two terms are going to cancel out because we have a plus b square root of b squared minus 4ac, and we have a minus b square root of b squared minus 4ac. So that's going to cancel out, which is good. And in addition to that, notice that also this second exponent is going to cancel out with the square root. So let's simplify this. So what else do we have now? So now we have that this is equivalent to b squared minus b squared minus 4ac all over 4a squared. Let's simplify this. So now this becomes b squared, and let's distribute this negative. So now that becomes b squared plus 4ac all over 4a squared. So now notice that these b squares are going to cancel out. So now they're going to cancel out, which is good. So now we're going to end up with the expression 4ac divided by 4a squared. Notice that the 4's are going to cancel out. So 4 divided by 4, they can cancel each other out. And also, a divided by a squared, well, this a is going to cancel out with the second exponent here. So after doing all that stuff, we have the expression c over a. And what this is saying is that for any quadratic, so let's just write it out. So for any quadratic function, the product of the roots, it's always equivalent to the expression c over a. And this is the main idea for today. Now, anytime that we have some kind of quadratic, if I would have added those two solutions of that quadratic, that's always going to be equivalent to the expression minus b over a. And if I would have multiplied those solutions, then that will always be equivalent to the expression c over a. So now let's put this into practice, because all we have done, we have just derived a statement, and let's use that statement and see if it's actually true. Well, let's take a look at example 1. It says write down the sum and the products of the roots for the following equations. Well, according to what we have just discovered previously, I know that the sum, it's always going to be equivalent to minus b over a. And in addition to that, I know that the product is going to be equivalent to c over a. So to just define the sum and the product of the roots, all we have to do is identify a, b, and c, and then just plug them in. But notice that in this case, my a has a value of 2, my b has a value of 12, and my c has a value of negative 3. So to find the sum, is going to be minus b, which in this case we know is 12, divided by a, where a is 2. And now we have that negative 12 over 2, well, that's negative 6. And to find the product, c over a, well, c is negative 3, and a is 2. Well, that's equivalent. Well, let's just keep it as a fraction, negative 3 over 2. But notice that here we're not saying what are the solutions. Here what we're saying is that whatever those two solutions are, which we're not going to find those solutions, you can find them on your own. Whatever those solutions are, if I were to add those two solutions, I know that it's equivalent to negative 6. And whatever those two solutions are, if I were to multiply them, that will be equivalent to negative 3 over 2. We're not stating what are the solutions. We're just stating two properties of those solutions. If we would have added them, that would have been equivalent to negative 6. And if we would have added those solutions, if we would have multiplied those solutions, it would be equivalent to negative 3 over 2. So let's just do another example, which the first thing that you want to do is identify A, B, and C. So in this case, A is 1, B is negative 8, and C is 5. So to find the sum, recall that's minus B over A. And to find the product, that is C over A. So let's just define that. Well, what would happen if I would have added both solutions for this quadratic? Well, that would have been equivalent to negative b, which in this case is minus 8, all over a, and where a is 1. So that will be equivalent to positive 8. And what would happen if I would multiply those solutions? Well, that would be c over a, where c is 5 and a is 1. So that's equivalent to just 5. And the last statement that I'm going to be discussing with you is that we can still use this property to go a little bit further. It's not just some kind of a algebraic way to just find the sum and the products, but also we can use these conclusions to write down a general form of a quadratic function. And that is that for any quadratic, can be written as f of x equals x squared minus the sum of the roots times x plus the product of the root. Let's do one quick example to demonstrate that. So we have stated that for any quadratic, if we know the sum of the roots and we know the product of the roots, we can properly define any quadratic that has that characteristic using this following statement. So let's just come up with that. So here we have two statements about a quadratic. I know that if I would have added the solutions, that would have been equivalent to 4. And I know that if I would have multiplied those solutions, that's equivalent to negative 7. So given that, we know that the equation x squared minus the sum of the roots, where right now the sum is 4 of x, plus the product of the roots, which in this case is negative 7. So let's just rewrite it. I know that this quadratic that we do have here, if I were to define those solutions, and if I would have added those solutions, it will be equivalent to 4. And if I were to multiply the solutions for this equation, that would have been equivalent to negative 7. And with this, it concludes our lesson for the sum and product of roots for any quadratic function.